So I wanted to talk about what I think Neuralink is getting wrong with their brain implants, and I think it has to do with this whole action potentials thing. So if you think about an electronic circuit, since when do you probe an electronic circuit and expect to get bursts of electricity? Better yet, since when do you probe it with a single probe and then expect to get the signal? Every other time you're probing a circuit, you have to have two probes, right? In your multimeter, you can't just take your multimeter and then have one probe sticking into your electronic circuit and try to figure out and try to capture the signal. You have to have at least two probes, right? You need the positive and the negative, but they don't have that. Now, maybe, well, this is just the wisdom of brain implants, is that you have these spikes, but I don't think that's the case, because think about your hearing for a second. Does it sound like it's spiky? Like it's pop, 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 bursts of electricity? Or does it sound like it's smooth and continuous, a continuous waveform? So if you were to probe in the ears, why would you get spikes of electricity? Shouldn't you be getting something smooth? Same with the eyes. Your vision is completely smooth. It's not pop, 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 pop. It's not this action potential stuff. So I think in the way they're probing, they're not getting the correct signal. Now I think how you're supposed to do it is by having an array of probes. And I know this has been tried before, but again, I think they were all single individual probes. They weren't pairs of positive and negative. You need to be able to get the continuous waveform. And then you should be able to get the actual signal from the brain. And furthermore, you should be able to, for the problem of jumping over a broken spot, like a broken part of the spine, it's a similar kind of problem where you just have to have enough probes in one side and enough probes in the other side, and then just send the signal over. But the signal you're sending over is not action potentials. It's not pop, 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 pop. It's got to be a smooth, continuous waveform. And so I think they're stuck on a probing problem. It's not a software problem, an AI problem. Because again, listen, just listen to around yourself. What do you hear? Everything is smooth and continuous. It's a continuous waveform, in and out, all throughout the brain, all throughout your body, throughout your hands and movement. There's this stuff, this piezoelectric fabric that I think would be an interesting avenue for research for them, where the fabric, it's able to generate a current, and you can send a current in and cause the fabric to fold, just like how our body works. And again, it's going to be a continuous waveform that you're sending in, and not one that's all poppy. Now, their robot for doing the surgery, couldn't that robot be used to put hair on my head? I think that would be a really good use for it. Or maybe that's what it was. But that's another interesting thing. They spent all this money and time building this robot to put in a brain implant, but it could be used to put hair on your head, I'm pretty sure. It's the exact same thing. Have a little, as long as the hair was designed correctly, and you could go around and poke it in and install the plugs or whatever. Now, just briefly going back to the action potential thing. Now, how I was saying, like, we'll just listen. It sounds smooth, and I know it is technically possible that if you align up a bunch of popping at the right time, it will sound like a smooth, continuous signal. But you still have to be able to probe to get all that popping to line up and reconstruct the signal to make that popping line up to be a smooth signal. So that would be an interesting experiment to do with like a rat or something, where you install one of these in its ears and try to use it as a microphone. Use the rat's ears as a microphone, and then do that until you're able to get a clean signal out of there. Then you'll be able to get a clean signal out of anywhere.